having a good day. And yeah, I'm decided to stream again the CPU Raytracer. I'm just checking. Yeah, the stream is looking good. Okay, lovely. Let me see if I can put my webcam a bit lower. I locked up my camera quite well. Okay, a bit lower, like this. Yeah, I think this is a bit better. It's a bit more natural. And let's see if it focuses on me. Yeah, sure, good enough. Right. So last time we were working on refractions, right? However, that wasn't quite working. So we can see here the following, right? Once it runs, right, we can see reflections are working, but refractions ended up with a black image. However, I think I figured out why that was happening. So what I wanted to do was, we have this hidinfo variable here, right? The hidinfo. However, this doesn't store the normal vector. What I want to do, because I keep getting the normal vector, but then forgetting it is in local space. So I'm just going to compute the normal once, so I don't have to read that about a million times. This would be transformed normal, right? And then in the reflection, we have, I think somewhere I can just steal this. Yeah, there we go. And then we can just put that in here. And then we say hidinfo transformed normal is equal to that, right? So now we have this hidinfo transformed normal. So that way we don't have to do this a billion times anymore. So we can delete this line here and then just replace that with this, with the transform normal, right? I don't think we have the get normal here anywhere else. No, okay, good. However, we do have that in the reflect, and we don't have to do that either anymore. We can just simply say, hey, the normal is hidinfo.transform normal. This is already good. Then in the refraction, yeah, I think, yeah, we're getting the normal here a bunch of times as well. So this would be the, oh, this would be info. Oops. Info.transform normal. And same here. I think, yeah, here we're getting it as well. We're getting the normal like a bunch of places. So we can just all replace these. And same with this. Right, and I'm curious if the Fresnel, right, so that, yeah, calculate Fresnel and that takes 90 transform normal, okay. So then in the Raytracer, in here I would need to change this to calculate refraction, and that would take the ray and hidinfo, right? And I think they should be fine, because I think the refraction is still set in the application. But we see soon enough, right? It's definitely struggling. I can already see that. What would... Okay, that is still very, very dark. Ooh, that's struggling. Let's change this. So instead of 1,000 cars, we have simply one. Is this like looking like a lot of cars? What would kill my performance for sure? Oh, wait a second. That looks decent. Okay. Let's get a few more cars so it's a bit easier to spot. Huh. Okay. That might be fine. So what happens if I increase the maximum depths in the Raytracer? I think it's like, yeah, it's currently limited to 3. So let's see what happens if we put it to 6. Because it could simply be that it's returning black because of the depths, or recursion depths. Oof, struggling with this very hard. Holy. It's doing something, that's for sure. I don't know what it's doing, but this might be correct. Ooh, that is struggling very hard. Okay. Let's try the following, right? So instead of the thing here, we put back this part. Yeah. And then we do need to put the camera closer, of course. Under the left, and this would be, I think this was like 15 before. So let's see what that does. Okay, that's completely black. That's fine. Oh, right. There is no reflection or refraction in these. So the cube has K1.material.refractive is 0.5f. Sure. Okay. Oh, I think we don't want to assign the, yeah, we're assigning here the default loaded material, what we don't want to do. So I don't need this. I don't need the rep material. I don't want to assign this either. Yeah, sure. I think this should be okay. Right, so it's completely black. I mean, that could have to do with shading. So let's bring the light closer, right? So we had the light at, oh, right, we can do this. And then put the intensity to like 100.f here. Wait, did my Visual Studio freeze? I think it did. That's annoying. Right, I'm gonna have to restart Visual Studio. Or at least it froze on stream, right? It didn't freeze on my computer. It froze on stream. Right, correct. Okay, so what happens now? Now the light is closer. Because it was a possibility that it was simply completely unlit. There we go, now it's lit. There is, however, no refraction occurring. What's interesting? Very interesting. I was hoping I would see some refractions here. Okay. Oh, wait, am I taking... Did I change it correctly in the Raytracer? Yeah, I am. Okay. So what kind of values are we getting from this, right? However, we do have the potato in the scene now as well. What's kind of... I mean, what we could do is move this in here. So Fresnel, yeah, the Fresnel is here, pretty decent fraction. So we get 0 reflection, okay. We get no refraction either. Okay. Yeah, because it's going to be black, right? Because this returns 0 if it isn't refractive at all. I don't think it does reflections now. What is fine, sure. Do I still somewhere else take the transform normal? You take the world origin. Yeah, sure. That's correct. Oh, wait a second. I see what's going on here. the ray itself was wrong. I put it in the wrong order. I have a different order here in this ray tracer than the other one. There we go. Now it's white. I guess that's progress. Sure. So what happens if I make the potato refractive? Because it's at an angle, it might be a bit easier to see. Refractive equals 0.5. So it's somewhat reflective. Sorry, refractive, sorry. Interesting. It is doing stuff, for sure. It almost looks like it's letting light through. You know what would help? I think we had the cube. Yeah, here. We had the cow one. What I want to rotate it again. And I want to move the build BVH in here again. Okay, cool. So this should properly build again. Oof. Okay. It's struggling very hard with this. It doesn't like this at all. It's really, you know what I think? It doesn't help the performance at all. My depth. The depth is actually really, really high. Let's change that to something actually manageable, like 3. There we go. That runs much better. Interesting. It's trying to do something, that's for sure. But I'm kind of curious about this part. The potato is refractive, right? So it might refract on the cube that's having these weird images. Peculiar. Okay. However, we can go over the algorithm or the function, right? Right. Let me open the refraction, and then the source code for it. The reference I've been using, right? Let me open these side by side. Okay. Give me a second to prepare this for the stream. Wait, stupid window. No, don't go. Okay, there we go. And then we go to display. There we go, finally. Okay. So this is the Scratch a Pixel source. And it has the cost ray function. Yeah, cost ray, right? And it does a bunch of things, and it says, well, blah blah blah, diffuse. Well, it's not diffuse in this case. It's it does the shading and stuff, right? Sure, but we don't care about that. Accumulates the contribution. Yeah, okay. Reflection. No, we have reflection and refraction. So say this is 0, 0. A Fresnel, right? This function here, Fresnel. Okay, yeah, here we go. We have the Fresnel equation, which is basically the amount that gets refracted and reflected, right? So what do we pass in? We have, I think we have pretty much the exact same here. -1, 1, to dot ray direction and the ray normal. Sorry, the normal. Then a tie is 1, and a tot is the refraction index. It's the same here, right? It's what's being passed in. Then if this angle is greater than 0, then we swap them. Then we compute some things, and that's a tie divided by a tot times the square root of the max of 0, 1 minus cosine cosine, And if this is greater than 1, then we return 1. And otherwise, we have this cos t, and that's the square root of the max, 0, 1 minus this, cos I, f absolute, cos I. If this massive function, this is the actual like formula for the Fresnel. I think this is doing the exact same. 8i cos I minus 8 cost, 8i plus cos I plus 8 times cost. Yeah. And then it's just rs times rs plus rp times rp divided by 2. However, this can be multiplying by 0.5. What is faster than dividing by 2, technically. Right, and then we have... Wait, this is interesting. They have an inline float modulo, and it's just SD floor. Okay, that's interesting. I haven't seen that before. Right, and then they have this, right? So then they get the interaction, right? They get the... We first check here if the... if it actually refracts at all. So if... Oh, wait a second. Yeah, so we first check if there's even a refraction index, right? Because if there's no refractive index, why even bother with this? Then we say, well, we calculate the Fresnel, but it's ray, transformed normal, and the refractive index, yeah? Then we have the GLM dot, and then we check if it's outside, right? And then we say ray direction, what's same here? And, oh, this is transformed normal. Right, that makes a difference. That could make a huge difference, right? Because then the inside-outside check is wrong, but would produce very wrong rays. Right, we can check this and see what this does. That looks better, I think. I mean, that definitely looks better, in my opinion. What happens if I increase the depth further to 6 again? Do I now magically get the background? No. Because if it's working correctly, right, I should see the background, basically. Let's put this to 3 again. Okay, let's go back. So we have the dot ray direction and the transformed normal. We check if it's outside or not, and if that's less than 0, right? Then we actually check, do we have Fresnel that we care about? Because if it's less than 0, or sorry, less than 1, that means there is actually refraction happening, right? Ugh. And then we have the GLM refract that takes in the following arguments. It takes in an I, what is the... Oh. Yeah, that's wrong. The normal should be the second argument, right? Because the I is the ray direction, the N is the normal, and this is the Fresnel. I don't actually know why it needs the... Oh no, it does. Yeah, that's actually important. Never mind. And then we normalize it. I think we can actually check if GLM refract normalizes. It might actually do that. Refract. Refract. No, it doesn't state that it's normalized. So to be sure, we do that. And then we say, let's test this again, because this could actually be the fix. Oh, there we go. That looks much better. That looks way better. And the performance is way better. I think the only issue now is the actual depth. So let's just continue the code observation, right? So we say, what were we, right? So we refract, right? And then we normalize that, right? Then the origin, yeah, we say the origin is outside, yes. Then we'll intersect minus the normal times bias. What's a small number? And otherwise it's plus this bias, yeah. And we say trace with the refractive ray and depth plus 1. Okay. And then we say reflect, what is normalize, ray direction, normal. And then we say, you know, I don't actually need this. Right, we can just call from here reflect. Right, so this was, so yeah, we had a reflection color. Oh, does this actually take care of the outside? Yeah, okay, it does. So let's actually keep this. Right, my bad. And we set that plus 1, right? And then we mix them in the following fractions. It's reflection color times Fresnel. Yeah. And then refraction color times 1 minus Fresnel. And then I return this value. If we don't do anything, we return 0. And then in here, we say the shading result. Well, that's apply shading, and we pass in the text color because it applies diffuse on there, times the reflectiveness. However, I'm not too sure about that. So I don't think we want to apply shading in this case. Because I think if we apply shading on this, it's kind of... Well, we do. I'm not too sure how to handle this case, because it's... what do you call it? It's being reflected and refracted, so it shouldn't do these parts. However, this is, I think, part of the Fresnel. Because I think technically, if something is transmissive, no, it can have a texture. I don't see why not. But it would be based off. Interesting. I will have to check that. All right, but let's go back to Visual Studio, right? And then just make this full screen. So, right, just to double check this image again. Yeah, because we can see the reflections here. Once it's... I think it's because of the depth. Yeah, I think you can see here, because of the angle, basically everything is being transformed. Right, so what happens if I increase the depth there, right? Do we get a better image? I think we do. Right, let me just take a GIF capture from this. Just for, I have a group that does this as well, so I'm just kind of curious about the results. Because this is kind of hard to debug, these things. Yeah. It's definitely looking interesting. But I just don't know if it's correct. Right, let's change this spec to 3, so it actually runs decently. And while this is rendering, I am going to be right back. Because I am going to get something to drink real quick, because my throat is really, really dry. And you guys can just watch this being rendering while I'm gone. Have fun. There we go. I'm back. And my hair is being really annoying. There we go. I think that's... this one is annoying me, this hair. Right, there we go. Okay. So, reflections and refractions. Interesting. So let's see actually what we're supposed to do with this. Because I'm actually curious about this. Right. So diffuse is very simple. But there's definitely something wrong here. I can tell you that for sure. You know what could actually be good? So in the refract, right? We move this here with the normal, but it would be better, I think, to move it in the direction, maybe. Right. Yeah, so there is another thing called Slick, what is a approximation of Fresnel. It's a bit quicker, but yeah. There's also Beer's law we could implement, what is basically... well, let me open this again on stream so we can actually see these images, right? So we can see different effects here, right? So these are cubes, cool, whatever. Diffuse, very boring. Then reflections, we can see the skybox. Then we have this. What is reflectivity and transmissions, right? So we say 10% reflex, but the rest goes through. However, this would actually be with a higher... yeah, this would actually be it, right? It would bend the light. This is just pure reflective, I think. I know, it doesn't matter that much. Fresnel basically causes this, right? So you can see kind of through it, it bends the light, but also reflects partly based on the viewing angle. And then you have Beer's law. Total reflection, what means if you hit at certain angles, you can't, it basically gets stuck. And Beer's law causes this, right? So it's very dark here, but very light at the corners. Right, so but we would need to know the array yeah, we need to know the distance it traveled through. What's kind of interesting, because we would basically need to know the previous rays, or oh, actually, I think we could calculate that, and then you get some really nice images like this. Right, so I think our reflectivity is way too high. Because I think we want to get rid of the reflective index. Yeah. So I think what we actually want to do is the following. So, okay, right. So this returns a Uh, so the calculate reflection, right? And this would take in another parameter called float reference Fresnel, because we would need this as well. And this was before here, right? This was in this position. And then we say in here, we just simply say Fresnel is equal to this, right? And then in here, it's obviously going to complain because we would need float Fresnel, and that's equal to 0.f. Sure, doesn't really matter. And we pass that in here. I pass the Fresnel, right? And then instead of multiplying by the reflective index, we would multiply by Fresnel. No, so yeah, it would be 1 minus... Yeah, 1 minus Fresnel. Because it's... If we go here, right, it's... this percent reflective. Yeah, thank you, Jinx. So that means that 70% would be... say this ends up being 0.3. That means 70% would be shaded of that reflection. Right. Let's see what this does. There we go. I think that's better. Yeah, and we can see as the angle becomes flatter, it should... Okay, that's kind of odd. Because normally the greater the angle, the more reflective it should be. However, it now seems as the angle is flat, it's reflecting a lot. So that's kind of interesting. Interesting. This is very odd to me. Like, it's actually really odd. Because it would make sense, right? Because if it's a flat surface, it would go through and it would be transmissive. You know what I could do is I could do the following, right? So let's go to the application. And then we put the potato, instead of to the left, we would put it to the behind it. And we would say, no reflection shenanigans, please. Thank you. There we go. So we can clearly see the object here, right? However, I'm going to need another object. I'm going to need a sphere. Because a sphere will actually verify me. Let me verify some things easier. Oh, I'm still corrupting my display. Whoops. Right. Local disk. Sorry, my mind zoned a bit out where I need to save them. Assets, and then we want a sphere. Sphere.obj. And I just found some obj code online for the sphere that I'm just pasting in this text file that I'm creating that you can't see. And then in here now we can change this to be sphere.obj. There we go. And now we should get a sphere. Okay. That is really trippy, holy. Okay, let's see if we can actually scale up the potato. Let's put this a bit further back to -15, but then we scale this model up. Set scale, so this would be, let's do it 3 in all directions. Let's see what that does. Okay, that's really, really interesting. This is so trippy. Because it's kind of looking like it's flipping the image. What's good, right? Because it's supposed to do that. However, I'm really not sure if this is correct or not. No. Because I think the normals are kind of like... You can see here, right? The normals are not that smooth. They're quite, like, sharp. Because this still... It looks interesting. But it's hard. It's really hard to verify if it's correct or not. Especially this part is bothering me a lot. This trade-on part. You know what we could do? Just to make sure, right, we're checking this function again, the Fresnel, this really calculated refraction, and I want to just double check if there is any get normals here. Or I could just do get normal. Right. Yeah, okay, so this would be, right, this is return, return in, no, sorry, hit info, world normal, or transform normal. Sure. Is there any other get normal? Oh, no, 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 no. This is not good. I wanted to just check in the Word document. Not everywhere. Oh, no. I made a mistake here. Hmm. Yeah, I think I may have crashed my Visual Studio. You know, the once now I've started streaming, I may have been realizing that Visual Studio might have problems. It might have a bunch of problems, and I'm finally beginning to admit them. Okay, so let's try this again, and we would search for get normal. C Okay, let me try this. C Spiferatables? Yeah, okay. I think I nailed it. Maybe, hopefully. Thank you for the follow, man. Why are you all giving me such hard names to pronounce? Right, okay, so this document is now actually correct. It only has one get normal. So that means that if, assuming I did all the calculations part correct, the refraction should be normal. Well, you know what we could try? We could try the following. Once it's done, right? Because the air has a refractive index of... Oh, wait a second. Am I actually doing this correct? I think refractive indexes are actually... Yeah. Okay, no. So it's definitely doing something wrong. Okay. So let me explain, right? So refractive indexes, I have like an actual science list of them. Right, so we have air is 1.003, water is 1.33, crown glass is 1.517, flint glass is 1.655, diamond is 2.417 for refractive indexes. However, we're saying it's 0.5, what would mean that with air, if it's 1, right, it would go basically straight. If it's 0.5, it would bend this way. If it's 1.5, it would bend the other way, I think. If that kind of makes sense. So these values are actually wrong. If we want glass, it should be closer to 1.5. There we go. I think this would be more correct. So what happens if I put this to 1? Because that would mean that the light passes straight through, basically. No refraction whatsoever. There we go. Okay. So let me rationalize this result that we're getting. This would mean that light passes straight through, or there is no... Okay. Let's see what these values do. So these normals are still fine. Okay. But I don't see any. I don't see the potato through it. What kind of bothers me? So let's turn on debug, right? And then in the Raytracer, we would have the Fresnel, right? So if it's greater than, I think this would be 1.f then, because otherwise it would be a weird result, right? So we have this Fresnel. Let's see what kind of values we're getting. Oh, wait a, this is never triggering. Huh? Oh. Yeah, repeater. I changed that to be 1 now for the testing. Sorry, my bad. And then this should not trigger. Okay, cool. So the Fresnel is almost 0. So that means that almost every... No, that means everything is refracted. Okay. Yeah, so it's less than 1. Okay. So the transmissive rate is the following, right? And this should be basically identical to the original ray, right? So we have the transmissive ray, what is minus this, and then we have the regular ray. Huh. So the y, this is odd. Because what's supposed to happen, right, it's almost not refracting at all. So it should pass straight through, basically. Okay. Sure. Oh, we haven't normalized it, actually. Sorry. Sorry, mom was calling out real quick. I need to help her with hear something real quick. I will be back in a few minutes. Sorry. Right, there we go. Sorry for the wait. Yeah, so, right, coming back to this. This is now the actual transmissive ray. This is now actually normalized. Okay. So outside the world intersect is correct, I'm guessing. Sure, I will believe that. Transmissive ray. Yeah. We did this, right? Sure, normalize, reflect, direction, normal. Okay. Oh. Yeah, there we go. So we're doing this here wrong as well. We're passing again, this is the origin, this is the direction, right? So this should now pass straight through and actually behave like it should. Let's, fingers crossed. That looks exactly the same. Okay, very interesting. Right, what happens if I turn up the refractive index now to a bit higher? So let's say 1.25. There's somewhere between glass and air. So it does something, I guess. Let's see what this does. It's still basically reflecting everything, it looks like it. Or is it just applying a lot of shading? Alright, so this would be glass. Okay, so next up we can try the following. So let's put this back to 1. Just so we can say it's air, it should pass straight through. Then in the ray tracer we say, hey, I want to apply no shading. So this would be just -0, right? This would be times 0. So we don't have shading at all. So now it's completely black. Okay. So why is this black? So let's go to debug and check this. Oh, right. If we don't do... No, we can do the following. So it would be... Well, let's not multiply this, but let's say... if hit info.material dot refractive index, if that's false, sorry, if this is less than, if this is equal to 0.f, then we apply the shading, right? Yeah, and we would do this, and then this would be in there, and this would just be return what is it, reflection results. So what does this do? Would this give me right, this doesn't give me this, right? Because now we're saying, oh, this doesn't refract, so do shading, but this doesn't do that. Okay. So what happens in here? Okay. So the transmissive ray is, let me think. So this is going to the left, up, and into the screen. So it's going like this way for me, although it would for you guys be this way. Anyway, it doesn't matter that much. What is the original ray direction? So the original ray direction is to the left, down, and into the screen. Okay. Interesting. So it's telling me then that it's flipping the direction. Very interesting. Because now this is going up very, very much. Huh. Right, I want to get a higher sphere model, because this one is not that great. This one is rather low detail. I mean, I could create one very easily in Maya as well, but yeah. Yeah, I think that would actually be easier. Let me open Maya real quick. Oh no, I don't have it installed. Of course I don't. No, I just want a sphere. I don't want like fancy things. How hard is it to get a sphere? There we go. I just want a simple sphere. There we go. I want this model. Download 3D model. Continue. Can we give me this model, please? Sketchfab. Do we have to be Sketchfab? Let me download the model. I just want the model. I just want the sphere. How hard is it to get a sphere model? Yeah, whatever. And then open. And can I now download the 3D model? There we go. But it's in STL format. But I think we can convert STL to OBJ quite easily with an online converter. These struggles of just trying to get them all. So the issue is, right, I don't have what do you call it? I don't have high quality, or sorry, I don't have primitives. I only have models, right? That means if I get a low quality sphere OBJ, it's gonna be quite hard to debug because the model is like, wait, I can actually show this on stream, right? Let me put this to release. Sorry, I'm choking my energy. So if we go to the normal view, right, we can see that this is very choppy. We can clearly see that it's made out of big triangles. Like the potato is much smoother, as we can see. So I'm trying to get a high quality sphere that that can it's much smoother. That will give me proper lighting. Okay, there we go. I think I got it. This sphere. Okay, I think I got it. Let's try this. So instead of applications here, we pass in, instead of this sphere, we pass in high-res straight of OBJ. So what would this do? That crashes. Why does that crash? Okay, so the OBJ is invalid. Okay. Maybe we can edit this OBJ. Let me share my screen. Display. Where did I put my display? There we go. So we can see that it's filter parse f on this line, blah 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 blah. So it's this one. So it was line. I think we had the ability to go to a line. No, I think there is the. I think I forgot what was the. Oh, there we go. I want to go to line, and it was this line. There we go. Go here. Oh my, this is bad. Right. I think this is fixable. So we want to replace // with space. So replace. Yeah, I think this is fine. Replace all. Okay, there we go. So now it's all gone. Okay, good. So that's, I guess, the issue from converting from STL to OBJ. We're losing some information, and it's trying to put it in there and be like, well, yeah, this is fine, but it clearly wasn't. Assets, and now we need to delete the BPH for it because it's invalid. Let's see what this does. Ooh, that's taking a long time to build. Okay. I mean, this sphere is better, maybe? I am not sure about that. So it's still rotating at what isn't great. Wait, was the old sphere rotating? I think it was. Oh, sorry, it's in the application file. My bad. So it was actually rotating. So what I'm curious about, if we stop the rotation, right? Does that suddenly fix our issue? And then we just do a sphere. So what happens now? Does it become see-through now? No, it's still very, very much dark. Okay. I really hope this would work, but that's fine. Right, so we go into the Raytracer. Then let's test this again, or see this again. So we refract. So what happened when I did do this? So we just say return this. Did this provide me with any better results than before? Yeah, so now we had the weird reflection type of thing, right? Instead of it being black. But I think this is just the result of the shading because the refraction isn't doing anything. So I think that's just causing issues. Okay. Because this is, if we put this back right, it's completely black. What would mean that the reflection and refraction return 0, basically. So that's interesting. So I did do this correctly now, right here. Yeah. Oh, wait a second. Should this be info.material.re the refractive index? Actually, it might be. No, that didn't fix anything. Let me actually verify that because I have my old Raytracer as well, right? I'm just curious what I passed in there. If I passed in the calculated Fresnel, or if I passed in the refractive index. So you had the yeah, okay, whatever. Work with me, Visual Studio. So we had the calculated refraction, right? And in here, I would pass in. Okay, I would pass in that, sure. Refract, come on. Huh. So, okay, let me actually show this as well, right? So apparently my refract is doing a bunch of stuff, but it's not taking the... Is this the Fresnel, actually? No, not quite. So I'm curious if the GLM refract is actually causing the wrong values. So in here, I have the refract right, and I pass in... Right, no, I just use the Fresnel for the final thing, right? Yeah, because it's the... And in this, it uses the... Yeah, refraction index, okay. So let's just copy this. But yeah, no, this looks like the Fresnel equation, though. As well, but it kind of looks like a modified one. Interesting. So let's go back to this and just put a... let's put the refract function in. Why the hell not? So this would be... Oh, no. Sorry, I'm copying the wrong function. That is correct, wait. Oh, sorry, it should be refract, my bad. Yeah, I copied the wrong function. So we have this, and then this should be a GLM vec3 refract. And this is also a GLM vec3 and a no, this can just take hit info. Right, and this is a const function, right? And then oh no, this should be just a vec3. And I think I could move this, yeah, out of class scope, right? And do the STD clamp, or let's do GLM clamp. And this would be GLM dot ray dot direction and info dot transform normal. And then this would be info dot material dot refractive index. And then GLM, no, we don't need, we can just say oh yeah, no, we do need that. GLM vec3 and is equal to hit info dot, oh sorry, info dot transform normal. I'm going to do STD swap, and this would be times n, and then this would be ray dot direction. Okay. Oh, right, yeah. So this would be a... So this was 0.f, yeah. Right, and then just an empty vec3. We don't really care about that. So we don't refract at all. Okay, so let's try this. So we say, instead of the GLM refract, where's the GLM refract? Wrong function. Refract, no. Okay, there we go. So this would be, let's just comment this out and make a copy of it. And then we say, well, this is equal to refract, and this would be the ray and info. This is not okay because, oh, this is supposed to be, yeah, this needs to be a const. Yeah. A lot of constants, right? So what does this do? I think I missed one. Okay, this does look much better. We can see now the potato through it. And we do see some reflections, what's a good thing as well. So what if I go now in here and re-enable this part? Yeah, so just this, I think. Yeah, what happens now? Right, so let's see what this does. Oh, this is good. This is actually really good. This is exactly how it should look. Right. Because this should be slightly dark because it's not getting a lot of light, what is okay. I think. And then the rest should be like going through because it is absorbing some of the light from the potato. Because it's going through and it's getting some of that, but it's a bit darker. But we can still see through it. And then this is completely invisible, basically, right? Because it's just shining through and it's getting the background, but it's very light. The background is considered fully lit, so there's no shading there. So I think I put this to 1.0, right? Yeah, there we go. So if I put this now to 1.5, that should flip the image. I think this actually would be correct. But it's a bit hard to see. Okay. So this is okay. So what happens if I do the high res sphere? I think, yeah, it was written like this. And then I knew that it was quite big. So let's put the camera a bit further back and see what that does. Oh. This is very interesting. I'm not sure if I'm inside of the sphere or not. That was weird. It's okay. Oh no. I didn't want to do it full screen. Enable normal view. Oh, yeah, I'm inside of the sphere. Definitely. So this model is apparently really, really big. Why am I going back with the camera? I could just scale the model down. Oh yeah, this model is huge. Holy. Okay. So 15.f. Okay. Put it back there, and then we say... Oh, it's scaled up as well. So 0.25. Okay. Let's do this. So now it should be 8 times as small, I think. Or 8 times... Yeah, 8 times smaller. There we go. I think that's correct. I think this is good. And we can see that these normals are really, really smooth as well. I think this would be okay, actually. So what happens now if I rotate it? I think we cracked the code, guys. The magical refraction code. So let me get a GIF of this as well. I like the GIFs because I can use them for a bunch of cool things. No, I think this is correct. The only thing that bothers me is that we're getting a shadow from it. But that's okay. That's something minor. No, I think this is working as it should. So just to verify again, if we go to the application, then we say the refractiveness is 1. So this would go straight through, right? Yeah, we can't see it. That's awesome. But we can see it in here. Oh. So if it's like very small, right? So if it's 0. Well, let's say it's 1.25, right? But now it's the cube. The cube should reflect actually. However, now the cube might be too small, but that's okay. Oh yeah, the cube is too small. So let's come and get this one and scale it up to two times the size again. And now we should be able to see, yeah, everything coming together. There we go. All that is looking good. And we can clearly see there's distortion happening in it. What's good, right? And we can see reflections as well in here. Like if it's angled, we can see reflections. You can see that the surface is becoming glossy. Oh, I'm so happy with this. This is really cool. This is awesome. I'm so happy with this. So, you know what I think I can do? I think I can make the material refractive. Sorry, not I think I can make it a color. So what if I instead make this blue, right? Does this take that into account at all? I'm curious about that. No, we don't get a blue U. That's a shame. I'm curious how I would need to take this into account. Because would I need to multiply the final color with the... How did I do this in my old Raytracer? Because I think I'm missing a slight step here. No, wrong model. That's wrong projects, right. So in the Raytracer here, we have the right. No. Right, we have the visualize normals false. Yeah. Yeah. So it adds it to the color to print. What I think is default to the object color. But that seems wrong. No, sorry. No, I'm almost certain this isn't quite correct. So I'm wondering if I need to multiply with the object color in here as well. That might be the case. So what happens if I multiply by text color? I think that might be okay. So we would say in, I need to get the correct project, of course. In the Raytracer, multiply by text color. And this would be, no, we need to move this down, these two lines. to here, yeah. And then we say times text color, right? So now we should get a blue sphere, right? Maybe? Because what is text color default as to? Yeah, the get texture. And I think this takes in the yeah, it multiplies or that returns 1 if there is no texture. Oh, so this just no, this doesn't you're right. This doesn't take the diffuse material in at all. Okay. So this should be the I think this should be the diffuse material. So this would be hit info dot material dot base color. So what happens now? This should be a blue U. No. Okay. Oh, did I make it? Yeah, I did a dum dum. So it's RGB. This is the B. It was a green U. Yeah, there we go. Now it's, but the background is green, right? So it only absorbs the blue colors, I think. Right, so that's an issue. We can't do that. However, if I now remove this, does it now actually take into account with shading? I think it might. Maybe. It's hard to say. It might, but I am really not sure. So I just want to put the sphere back on. So instead of the cube, we do the high res sphere. Oh yeah, that was the big model I forgot. Right, so this needs to be smaller, and this needs to yeah, we need to make the sphere smaller. I can't get my words out. Holy. Right. Right. No, but I think this is actually correct. This looks actually very good to me. It shouldn't be casting shadows though, because it's like the light is supposed to be able to travel through it, right? Because it's refractive. However, we're dealing with the issue that if it hits a refractive object, right, the light could get through it, but it would be bent, and that would be problematic as well because reasons, right? But I think this is reasonably accurate. At least it looks to me. So what happens if I turn the potato now to refractive? So this would be 1.5, right? 1.5F. So now the potato is also refractive. Ooh, that's interesting. But no, that seems correct to me. I think this actually is correct. Yeah, I'm happy with this. Yeah, no, this is cool. So, you know what it's time for. My favorite part of everything, and that is Git Kraken. Because we are going to actually need a new commit message. Oh, and right, we can't see the commit message here because Git Kraken is taking up my entire screen. Right. There we go. Okay. So we would Is it? Wait, why do we only have 6 files to stage? That seems. Oh no. This is okay. Well, this seems about correct. So stage all files, and I might have made a mistake here with the whatever. Okay, so we added a scene BVH. Yeah. Can I merge these two? Nah, okay. I think we'll just have to live with the one really horrible commit message. I will accept that. So we added a BVH to encapsulate all shapes in the scene, and then added refractions, and then commit changes, and then push. Yeah, let's rename this. Edit commit message. So this was working on scene BVH. Working scene BVH. Work in progress, right? And then update message. And then boop, that gets branched and it gets retargeted, and then we push that. Okay. Yeah, sure. Okay, then we do this, that's that, bam. Okay, I think this is now pulled successfully. Okay, and then merged. Okay, I think this is correct. Maybe? It's looking fine. Because if it changed, it should... No, okay, it didn't change. Okay, very, very cool. Because if it's merged incorrectly, it should... Ooh, I do actually... Ooh, I don't think we want this file. I think this is a I'm GUI file that basically stores where everything was, like the doc spaces. Yeah, I think that's not ideal, but whatever. Oh, whoops, it's the wrong right, the wrong GitHub. Sure. No, but this is fine. We re-merged it. It's working correctly, so that's cool. Let's go to boards and check actually how we're doing. So I'm GUI. Good. So we had refractions in progress. Very cool. And it's actually done. So what I actually want to do next in this stream is seeing if I can visualize the pixels, how expensive they are. However, I'm curious how I can do that, because it's kind of a interesting problem. How do I define how expensive a pixel is to render, right? Because I'm going to need some way to either, because recursion plays a depth, but also the number of intersections play a role, right? So I need to express a complete way for a pixel to express how long it took to render. One of the things I could do is in the jobs provide a, or I could put a timer. No, but that would be problematic as well. Okay, we can check the internet, like how people approach this. Because I know it's possible, right? Yeah, because because we want to be able to see, right, if a pixel is expensive or not, right? Because what we should see is basically the following. If it renders, right? So air pixels would be very, very cheap to render, but these pixels are very expensive to render. where the sphere might be slightly cheaper than the potato, for example, or the sphere might be more expensive because it's higher quality, more triangles, right? So I want to visualize that. Uh, all right. I mean, of course, Yako has written a paper on this. However, I'm not sure if this will help me with my problem. I mean, this doesn't show me the cost. I think. Hmm. Because so Yako Bicker, for the guys that or is it Bicker? Sorry. He's actually one of the teachers at school, and uh, he is Yako Bicker. Sorry. He is basically an expert in ray tracing. Um, so he has written a bunch of papers on it as well, and yeah, his sources are always, if you search anything for ray tracing related, you will most likely find one of his papers, and they're usually very very helpful depending on what you need. However, the paper I just found wasn't quite what I was looking for. Oh, but I just find another thing, another presentation by Yako. Let me see if I can find an example in this. No, this isn't quite correct. Um, hmm. I'm hoping this, as an example, this one I've opened right now. No, 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 no. Just looking for an example to show you guys on stream, right? So sorry for that. So I think it's actually in the accelerate lecture, what is about accelerating ray tracing. What might go in? Yeah, it goes into hierarchies. Okay. No, no hierarchies. Yeah, very cool. Nah, that doesn't show the image I was looking for. Right. You know what? Actually, I think I accomplished what I wanted to do today. I wanted to add the reflections or refractions. Sorry. So I think for today I will be ending the stream and do a bit more schoolwork because today is one of the days I can work on personal projects. Uh, so we'll see if I can attend some other lectures. Maybe I will see what I do. And I want to thank you all very much for watching the stream, and I hope to see you all next time. Thank you for joining the stream. It was a bit of a short one, but we